Once the welding is over, the welded part will be removed from the chuck for the examination. When you are changing the material, the process parameter, we can have different micrograph like this. This is the effect of welding variable on the process size zone at the flash formation of inertia weld. When it is low, we can have this kind of process size zone at the interface. When the parameter level is medium, we could achieve this kind of weld beat. When it is a high level, velocity is high, flash formation will be like this. When the pressure is high, we can have this kind of joint, also the flash formation. The friction pressure, the weld made at the low heating pressure are similar to the weld made at the high initial velocity with regard to appearance of weld upset and HZ. Excessive friction pressure produces poor weld with poor bonding at the center, having large amount of weld upset, as in case for weld made at low velocity. But optimal heat pressure ranges for weld in the solid bar medium carbon steel is 150 to 205 Newton per mm square, which we have received this value from the literature. How weld properties vary due to the rapidity of heat generation produces an almost narrow heat affected zone due to good control of temperature, and as plastic material is subjected to hot working during heating phase and to colding working during the forging phase. This results in the weld with extremely fine grains. Metallurgical examination shows no evidence of melting, as the measured temperature for steel are usually in the range of 1260 to 1330 degrees centigrade. However, rapidity of friction welding leads to high cooling rates, which results in higher hardness of weld zone. Satisfactory weld between aluminum and stainless steel can be produced without the formation of brittle intermetallic compound layer. These are the part which can be produced by using rotary friction, which is widely used in the automobile industry. The first picture shows the propeller shaft and drive shaft, and also produced by rotary friction welding technique. Next one is camshaft, and then the third one is drive shaft, intermediate shaft. These are the applications when we are preferring cylindrical component for going for rotary friction welding technique. These are the another applications made by the rotary friction welding for the automotive industry. These are the few advantages of rotary friction welding. Do not form a molten pool, hence solidation defect or hot cracking porosity segregation are reduced significantly. Suitable to weld a dissimilar material joint. Localized intense deformation and high temperature result in the decrystallized microstructure, producing an overmatch in tensile property to parent material. Processes possess a self-cleaning ability due to wearing action, which is also called eco-friendly welding technique. There will be no smoke, no fumes during the welding process. There are some limitations when you are preferring rotary friction welding, not suitable for asymmetrical geometry components, large cross-sectional area with CDF, difficult to due to the limited available power input, thin wall structure like tube and plates with ROW elements is a very good challenges. Another one case study is here I'm going to represent completed the C major. We came across many alloys like A6061, 7075, T651 condition, also 6083, 2025, 508. These are the alloy we used to join by using our machines, which is available in our center. Also nickel super alloy for GTRE Bangalore, we did one small work for joining nickel Inconel 718, Inconel 600, and Nemo 230, which is advanced steel material. Also margin steel, Marcetic stainless steel, ASI 410 and ASI 444. This is a machine available in our center. These are the few fabricated joint dissimilar steel to aluminum. The first photograph shows the steel to aluminum. This is the aluminum part, and another is steel. Has been joined successfully by using our facility. Here you could see the similar joint of aluminum. Both the cylindrical parts are made of aluminum. For the application, we went for similar joint. Here you could see the stainless steel with a super alloy. Another one is a steel to steel joint. Here again we have chosen titanium alloy, nickel alloy, cobalt alloy are exclusively used in aircraft industry and defense applications. The utilization of super alloy has been increased in high temperature applications over the past few decades because of physical characteristics such as high strength, greater toughness, fatigue, clip strength compared to other alloy, and high corrosion resistance. Among the various super alloy dissimilar joints, when we prefer fusion welding techniques. This is the turbine assembly where you need to join two cylindrical path here by using rotary friction welding. This is a video of our machine. We used to join the 718 to MSS. The chemical composition of Inconel 718 and chemical composition of MSS is here. Also the base materials of base metal tensile properties is given in the table. The welding parameter which was used to fabricate the joint, that rotational speed is about 2100 RPM. Forging pressure was 2.15 tons and forging time 8 seconds. Friction pressure is about 2.15 tons. Friction time is about 8 seconds. Based on many trials, we could achieve these parameters for fabricating joint without a defect. This is a photograph of defect-free joint. Here you could see the micrograph of the weld joint, which is similar to that of linear friction welding macrograph. After the welding, we are sectioning the weld. This is a cylindrical part that the earlier one was the plate to plate, which is similar almost. We can through the rotary friction welding, that similar microstructure, like that zone is almost similar. Weld center, thermomechanically affected zone also available in this micrograph, also heat affected zone. After the welding, we used to extract the specimen from the weld to conduct the tensile test. This is the photograph of the smooth specimen before weld, mini tensile specimen, which we are preparing based on the ASTM standard. This is a photograph of tensile fracture specimen after conducting the test. How we are conducting the test is the photograph which clearly shows. The tensile properties is given in the table. From the above tensile properties of dissimilar joint was recorded the maximum yield strength 563 megapascal, tensile strength is about 901 megapascal, and joint efficiency is about 87%. In this dissimilar joint, failure occurs at coarser line S80 site thermomechanically affected zone. The strain has measured through 8 mm dextrometer, which record the strain rate of 11.7% and elongation is about 31.6%. Also, even for hardness, because of the dissimilar material has been preferred, the hardness is higher at the side of S80, which is around 300 HV. The hardness is decided based on the microstructural features of different material, which is to be welded by using rotary friction welding technique. Again, here we are going to talk about the material which is used for naval application, DMR 249A grade, which was supplied by DRDO Delhi for conducting the test, which is widely used in ship hull structure. DMR 249A grade is used for making ship hull structure. This is the base metal and filler metal chemical composition, also mechanical properties of DMR 249 is given in the table. This is the microstructure of the base metal, optical and semi-microstructure. Here we could find the microstructure like perlite and ferrite, which is available in the base material microstructure. Average grain size is about 18 to 12 micrometer. The joint configuration, the plate thickness was 12 mm. We have prepared beveled edge for making a joint. We gone for two different welding techniques like GMAW and SMAW, which is available here in our center. This is the welding parameter which was used to fabricate SMAW process and the GMAW process for making welding. These are the defect-free welded joint, SMAW, and this is the defect-free welded joint of fabricated welded joint of gas metal arc welding. After the welding, we have extracted specimen,
என்ன பண்ண சொல்ற?
smooth specimen and not
சொல்லு.
stencil specimen. Also,
இப்போ கடைக்கு வரியா? போய் வாங்கிட்டு வருவான். வாங்கிட்டு வருவோம்.
impact testing and friends, please mute your mic.
சும்மா சார்.
Please
செஞ்சு
mute your
சாப்பிட
mic.
வேண்டியதான் வீட்டுல சுண்டல்.
Sir,
Sir,
Velmurugan
sir.
sir. Sir, Velmurugan sir, kindly unmute, sir. Sir, kindly participant cooperated. So don't disturb to presenter. So kindly cooperate. This is the end of the today ending the session. So kindly cooperate.
Thank you. Also, we have
Okay, sir.
prepared testing specimen and fatigue specimen. These are the specimen extracted from the weld joint. First photograph shows the before weld and the after weld. This is the impact specimen photograph and the after impact test photograph. It has been conducted successfully. We have the facility to conduct all the tests at our images center. Here you can see the mechanical properties of weld of both SMAW and GMAW. Ultimate tensile strength is higher compared with the Schilder metrology process, which is about 570. Elongation is also higher than the SMAW process. But the failure locations occurred in both the process HAS base metal interface in GMAW also. See, that fracture looks like a cup and cone fracture. Here the photograph is the evident to confirm the cup and cone fracture. Hardness has been measured at the across of the joint at the mid thickness. Here you could see the SMAW joint hardness is comparatively lower than the GMAW process, where the weld naked zone, the fusion zone shows the very lowest hardness weld zone, then the finer grain HIZ and the coarser grain chains of both sides. But the hardness reduced only because of the hardness decreased at the HIZ to base metal interface region. Here you could see these are the failure locations. This slide shows the microstructural features of fusion zone in SMAW. Whitman Staten ferrite structure were achieved, and GMAW acyclor alpha structure were achieved. And this is the upper bayonet microstructure and in both sides. Again, we confirmed acyclor ferrite through the TEM images for the SMW process, and lower bayonet has been confirmed through the TEM images processes GMW. Here you can see the micrograph of the HIZ of various region, coarser grain HIZ and finer grain HIZ, GMW process for coarser grain HIZ and finer grain HIZ. Here there will be a variations in the interface of weld metal and HIZ. These interface regions of various zones. Why weld failure occurs? Because of the low hardness plus grain deformations, which confirm the weld failure. It has been confirmed through the same fructography of notched and notched tensile specimen. Large population of fine dimples were observed in the SMW process and the GMW process. The SMW comparatively a higher large population of dimples were observed. For the notch specimen, we have observed voids in the middle. The same fructography of impact specimen is a dimple and voids were achieved. These are rotary beam fitting machines available in our center. We have conducted the test. Also, we went for the flat specimen fitting test. Installed machine also available here. These are the specimen which was prepared to conduct the both rotary beam fitting and fitting specimen of before test and after test. Fatigue property again you could see, which is SMW process is almost here. For the intercept, it is closer to the base material. Fatigue strength of notched specimen is 364 megapascal. For GMW, it is 353. For SMW, is around 351. This is a scanned image of fractured specimen. That 1, 2, 3. It shows the crack initiation and crack propagations. And third one is the final failure. This is some fractograph of SMW joint. Scanned image of fractured specimen. Here, similar trend were observed. Crack initiation and propagations and final failure. That 1, 3 indicates the different images here. How crack propagated continuously and this end with the final failure at the third stage. Same photograph of GMW joint. This is a scanned image. Again, crack initiation is clearly visible here, which is crack initiated here and propagated up to this stage. When they are reaching third stage, final failure will occur. These are the important findings from the study. The stress ratio are become more positive, which is equivalent to increasing the mean stress. The measured fatigue limit become greater. The mean stress become more positive. The allowable alternating stress decreases. Therefore, fatigue type of base metal SMW and GMW joint will be in which bead condition the fatigue performance will lower than the without bead specimen. Also, the bead has act as itself stress concentration area. Another one is the additive manufacturing studies by using CMT process. India is a design and development of low cost energy efficient additive manufacturing technology using CMT welding technique for aluminum of high strength low alloy steel component. One of our student did this work. Yesterday, I was watching one professor was talking on this additive manufacturing process. These are the component which can be produced by additive manufacturing process. Application of cylindrical sleeve and roll of aluminum where it is widely used. The problem is given here why we are going for additive manufacturing technique, and solution also given among the various process. The CMT process seems to be one of the more suited for worm because CMT have advanced dynamic current wave of generate a small molten droplet at the tip of the wire, which are attached at a low current with the help of mechanical attraction of the wire. The result in high deposition rate, low heat input is a very important one, and high bead layer quality, production with stable electric arc and without spatter. The spatter is the things why we prefer additive manufacturing process. It is believed that low heat input CMD technique can reduce grain coarsening, segregation of second phase in the grain boundaries, and pore formation across the depositor direction, result in a more uniform microstructure and isotropic mechanical properties along the build direction. The cast component versus worm component is given here. They have compared with the radar chart why cast component strength versus worm is very important is given here. The various component of worm system, CMD process. The setup is available at our center. This is a process parameter which was confirmed after many trial. CMD worm process during the welding. One of our student has taken the photo. This is a cylinder based on the application. They went for making the cylinder both GMW process and the CMD process. Here the bead appearance will show the difference how both the cylinder is look like. After machining, we achieved this kind of cylinder. They have extracted a specimen from the cylinder or conducting the tensile test. This slide shows the before test and after test. Evaluated mechanical property, they have extracted samples from top bottom, both the top bottom, to confirm where the weld quality is good by comparing GMW and CMT process. They have compared the mechanical property, how mechanical properties vary through the after the GMW and the CMT process. They went for the cost analysis to confirm which one is the best. They have given the reason why the weld is improved in CMT process because low heat input is the reason. The video. CMT welding generate only 1/10 of heat that MIG welding does. The heat input is the major role to confirm the weld strength here. They went for cost analysis and energy analysis. Important findings given after the process. The UTS of CMTW component is 18.13% higher in the bottom region and 15.17% higher in the top region compared to the GMW component. The elongation of CMTAW component is 31.08% higher in bottom region and 19.41% higher in the top region compared to GMW component. The impact toughness of CMTAW cylinder is superior compared to GMW cylinder irrespective of region, that is both bottom or top. The hardness of a bottom region of CMTAW component is 24.05 higher than GMW component. Similarly, the hardness of top region of KW component is 18.10% higher than GMW component. Another study is on high strength low alloy steel component for offshore and onshore structure. This is the application of HSLA steel, where it is used in oil and gas industries. They have found what are the problem in the casting process and other process. Here they have compared solid wire and metal core wire for making cylinder. Again, they extracted the specimen from the cylinder to conduct the material test, mechanical test. They have extracted both the bottom region and the top region to conduct the tensile test. This is the very good microstructure obtained by using solid wire and metal core wire. You could see the variations on top region and bottom region. Bottom region microstructure will be finer than the top region. Here, even for the EBSC study, for confirming the grain size distribution of bottom region, and the top region, how grain growth occurred. The student has been explained by the schematic representation. These are the important finding after the studies. The MCW component has finer grain than the SW component, and with more grain count, regardless of pillar wire, bottom region exhibited more grain formation with finer grain. Similarly, the HAGB formation was higher in the MCW component. The high angle grain boundary formed during recrystallization play a critical role in hindering dislocation movement and causing pile up by enlargement, thus enhancing the strength of deposited wire arc additive manufacturing part. These HAGB allows more atomic diffusion and dislocation in the matrix, resulting in the creation of highly strained and thermomechanically stable matrix. The matrix will then tend to produce a randomly oriented crystal nuclei with a more significant number of residues which strengthen the matrix. Due to the finer grain and HAGB formation, the strength of MCW component was higher. Thank you for patient listening. My talk. Is there any queries from the participant?
Thank you, sir, for your nice presentation. Participant, if you are having any queries, means you can you can ask.
Sir, good evening, Professor.
Good evening, sir.
Sir, this is Anbarasu from Vellore Government College, sir. Sir, one small doubt, sir. This rotary welding, why we are calling it as inertia welding, sir? Inertia friction welding.
Inertia means there will be a flywheel. If you use a flywheel, once the motor start the flywheel, it will be stopped after some time. Then flywheel will keep on rotating to make a weld.
So initially, we are giving the maximum speed, then we are stopping it.
Yes. That is clearly shown in the video which I have played
Yes, sir. Yes.
for joining very big cylinder component. There you could see when you play the video, you can understand that.
Nice presentation, sir. Sir, so the overall your work is on SMA.
Only on welding.
Yeah, only on welding. SMA
No, I did both rotary welding and linear friction welding. Other things are done by the scholar, those who are presently doing research in our center.
Nice, sir. Thank you, sir. Nice presentation, sir.
Thank you so much. For my PhD also, I did friction stir welding, which is also coming under solid state welding. Then I moved on to linear friction welding.
Yes, Professor.
So I did
this one also. I had a doubt. What is the basic friction welding is there? Friction stir welding is there. This rotary friction welding cannot be called as friction stir welding. Yes.
Yes.
What is the
but both are coming under friction welding.
Yes,
in friction stir welding, there will be a tool, rotating tool, which will be inserted to the plate. After insert to the plate, it will make a stirring action in the plate, inside the plate. That is why it is called friction. There will be a friction and stirring. In rotary, there is no tool available. Both the path will make a joint. There is no tool in the rotary friction welding. But in the friction stir welding, there will be a tool.
Yes, Professor. One more doubt.
Stirring action.
The cylindrical kind of welding, rotary friction welding, we are doing cylindrical kind of jobs. Other than this friction welding, previously, what kind of method they're using to join those two cylindrical components, Professor?
Cylindrical component can also joined by fusion welding technique like GMAW, GTAW. It is possible.
Fusion welding only
but the joint quality is good when we are preferring rotary friction welding technique. Joint quality is good.
Yes, Professor. But the welding will be happen only in the circumference, not in the middle portion, sir. Yes, Professor. Will happen throughout or yes?
It will not happen at the middle portion.
Will not happen in the middle portion.
For that, we need to make
we are getting the advantage of the complete welding, even at the middle portion.
Yes.
Thank you, Professor.
You can go through the literature. You can have many details.
Also, Professor, I have one doubt. This is regarding my work. What is the currently working coating facilities there in Annabelle University, which is at function? Any coating facility?
Plasma coating is available, but currently it is not working.
Okay.
But we don't have operator to operate the machine. Earlier, we have the scholar. It was operated by the student, but now they have completed. Now the machine is ideal now. We need to repair.
Okay. Any plan of okay, yes, Professor. The
If it is there, definitely I will inform to your coordinator, Professor Tirumala Kumarasamy. He will let you know.
Sure. Thank you so much, Professor.
Thank you.
Sir, how can additive manufacturing 3D printing be integrated with the traditional welding method, sir? That is I don't doubt, sir.
This is a layer by layer depositing technique.
Okay.
That is why it is good. Also, the tensile strength also good comparatively compared with the other welding processes. Here they have compared GMAW process and CMT. Due to the less heat input, we could achieve very good fine grain structure compared with other technique process. But I am not familiar with this process. This work was done by one of the scholar who is currently doing PhD here.
Okay, sir. Sir, if sir, how can that is artificial intelligence and like machine learning will optimize the welding parameters, sir? Like that is advanced.
There is a different technique. Our students are used to go for response surface methodology, RSM technique, and other technique. they will
Okay, sir.
use these techniques for optimizing parameters.
Okay, sir. Okay, sir. Okay, sir.
Good
Thank you.
afternoon,
If
sir.
you are
One more
familiar in
question.
AI and other technique, you can apply.
Okay, sir. Okay. Okay. Okay, sir. Yes, sir. Sure,
Sir,
sir.
one more question. Hello.
Yes. Yes.
Sir, additive manufacturing mainly disadvantages. Anyone, sir? Additive manufacturing.
Disadvantages is initial cost is high compared with the other welding techniques.
Time is save, sir.
Time save அப்படின்னு சொல்ல முடியாது நீங்க.
Okay, sir.
Process is a latest version, but cost is more
Cost is
compared
more.
with other welding machines.
Time is more.
Time will be taken more. Time will be taken more.
Okay, sir. Okay, thank you, sir.
But complicated shape can be made. Intricate shape can be made through 3D welding.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
Participant, if you are having any doubt, means you can ask. Otherwise, we will continue the Dr. S. Sabri sir session.
This meeting
Sir.
is being
Am I
recorded.
audible?
Yes, sir. Sir, audible, sir. Audible. Participant,
Thank
if you are
you.
having
Thank
any
you.
queries, means you can ask. Otherwise, we will wind up the session.
Thank you, Mr. Balamurugan. Sir is thanking me through.
Thank you, sir. Thank you for your wonderful, nice presentation, sir.
Thank you. Thank you. Once again, I'm thanking the coordinator for the opportunity. Thank you. Thank you all.
Thank you, sir.
Okay, sir. Okay. Participant, you be patient. I will call Dr. Sabri sir to continue the second part of session. So keep patience. So the feedback link from AICT FDP portal till not process. Tomorrow, I think they will be processed because we have to upload the attendance in AICT FDP portal. So be patient. Tomorrow or tomorrow evening itself, we open the feedback. When we fill the attendance means automatically AICT website they give the option of feedback to fill. So don't worry about that. Tomorrow we will rectify that feedback through your login, individual login. This is the last session, participant. We keep patience. I will engage with Dr. S. Sabari sir. Second part of session will we continue, and this is the end of the last session. So I make a call to Dr. Sabari sir. They will be joined within a few minutes. So the participant, I shared the feedback session 11 and 12. You can fill out by the link by using the link Google form. And also assessment will be before 8. You have to complete the assessment because after completion of this assessment and feedback, they will be consolidated and we have to update tomorrow in AICT website. So after then the feedback option will be open through your individual login. So after that we have to get a certificate. So okay. If you're having any doubt means you can put in chat box. I will reply that message. Okay, sir. Be patient, sir. Sir will be in connected. Okay.
Hello, can you hear me?
Yes, sir. Yes, sir. Here, so your voice audible, sir. Audible, sir.
Okay. May I start my presentation?
Yes, sir. Yes, sir. Continue, sir.
Okay, thank you. Okay, so good afternoon to everyone again. So I am here to present on another topic. Okay, so this topic will be in a very crisp presentation. I'm not going to talk much, but just I want to give an introduction about this material to you, just bringing to your notice so you can further go on through this topic. Okay, these have a greater potential nowadays. Currently, I'm also having one project proposal which is recently submitted to a European Union project. So these have a greater potential for the projects and everything. I think in the year 2020, 2021, I guess, we also submitted a proposal for an Indo-Portugal project, collaborated with a professor from IIT. University from India and university in Portugal should collaborate. That's the objective of the project call. So we applied for a project based on this. Our score was very good, but it is, unfortunately, we couldn't able to get the funding, but our score was just below the selected projects. Of course, the project is very limited. I think there are 10 or in the range of 10, so it's very limited. So the reason why I am emphasizing is this is a very ongoing topic. Okay, so the presentation title is Autonomous Repair, the Emerging World of Self-Healing Materials. So what is self-healing materials? Why we need these self-healing materials? Okay. Before going to the self-healing materials, let me give a small introduction about the United Nations sustainability goals. So these United Nations sustainability goals is a major it's creating major impact in regularizing the industrial standards related to development of the workers, development of the industry itself, and also, main importantly, the preservance of the nature. So one of the important factor they are bringing is circular economy. So circular economy is, by the name says, we are creating a product, let's say a car or something, let's say a wind turbine, and the turbine is under in service, and after the service it should not go to a yard, a scrap yard. It must be recycled for other purpose, which contributes the economy, which must create a job, which must act like a resource for another application. So this is circular economy. So all the products, imagine we are having many products, all the products is turned like a circular economy, means we don't have any waste, and if we don't have waste, we don't want more material. The consumption of the material will be very lesser if we try to recycle or circulate the material in various forms of various usability. So that's circular economy. So this is a very important topic. So the research scenarios around the circular economy is most wanted, and it is very important for the planet. So then the sustainability, okay, sustainability is also related to that. This must be adapted or clubbed together with the industry 4.0. So that is the key objective of the United Nations development goals. So coming to the real topic, why I am giving this introduction, because the topic is more relevant to that, to circular economy, sustainability, and saving the planet. So the first one is motivation. I want to create the motivation for this presentation. The first case study I have taken is repairing of the bridges. So why we need a repair of bridge? Of course, the bridges, or there are different kinds. One is metal based steel bridges, which are widely used nowadays. It was replaced by the concretes, but still there are a lot of places we are still having the metal bridges. And the bridges are not only infrastructure, but also the key parameter for the development of that locality, because it's allowing the business generation, it allows the transport or migration of people. So that is very important. So when there is a repair, you need to stop the traffic. And if it is a metal even there are some bridges over the sea. So there are many chances where the repair is really really difficult, and it is time consuming, and it must have the expertise of a civil engineer, architect, material scientist, logistics guys, testing guys, characterization guys, like NDT testing guys. So it's a very very difficult task. So the next case study, just to put in front of you, is repairing these oil refineries. Let's say even repairing the ships. They are far away from the land. So in order to go there and repair, it's really really risky, and it involve the prices involved on taking the personals, the equipment to repair. Uh, the equipment to evaluate the existing structure. So the prices involved and everything is really challenge. And moreover, when you are going for a repair, then for example, a part is damaged. What you will do? You will cut the part and you will replace the part, and you need to carry the waste to your homeland. So again, it's not only travel to reach there, but also travel to remove the scrap from there and to bring it here. So this is also another challenge for repairing. And then another challenge. Imagine in the space station, you have a lot of debris may be there, or you can have a micro level, micro or meso or macro level products. The space products may be there. So this may damage any part, and we don't know where it was damaged, and we don't know how to repair it. So if, for example, in our case, if we have a repair activity in our house, we are even we are now struggling to repair anything from our house. We don't have enough people to repair, and even if we have people, they don't come at time. So the repairing is always a challenging, but in this case, this is really expensive on repairing. So how can we overcome this problem? We can overcome this problem by having some technology called self-healing, which means if you have a damage or if you have something wrong there, the system itself or the material itself heal themselves. This is not a new phenomena. This is a old phenomena which is available in the nature. For example, this phenomena is available with us. We have a small scar or we have a small damage in our skin. We don't need to apply any medicine, or you don't need to cover it or anything. Even if you leave it, it can automatically, the body itself have the healing capability, and it will heal. So we want this kind of phenomena for the metals. For example, in the skin and in the muscles, the chameleon can heal. Okay, it's not healing more, but it can change its color. So it due to the some kind of simulation stimulation, let's say the color of the substrate is adapted by them. And if you take a lizard, if the tail cuts off, it will automatically generated, and if the feather falls, it will come again. So there are a lot and lot of uh, uh, we can inspire a lot of things from the nature that have the self-healing capability. So now we want this phenomena to be in the material, but it is really challenging. So these are all the engineered self-healing materials. So the self-healing can be defined as the ability of the material to heal itself when they are subjected to some kind of damages. So this recovery can be autonomously. So they can do by themselves, the material itself they can do by themselves, or with the response of an external stimulation. Okay, so there are many type of there are many materials is comes under this one, but the major category is this autonomous